So it is time, so we'll begin. I want to welcome everyone to Contributed Session I on Labor Markets and Migration. My name is Seth Murray. I just want to begin by setting a few ground rules for the presentations. We have 3 presentations today, each of which will be about 30 minutes in length, and we'll be allowing for questions throughout the presentations. So if you want to ask a question, please just use the Q&A function, type in your question there, and I'll try to be paying attention to that and to recognize you and allow you to unmute yourself to ask your question. We'll potentially also have a little bit of time at the end of presentations, depending on how active the conversation is. We may have some time at the end of presentations for a few questions as well. So with that, I'd like to kick things off. We're going to begin with the presentation from Anthony Savagar from the University of Kent. He will be presenting his paper called Product Market Concentration and Productivity in the UK. Go ahead, Anthony.
Thanks, Seth. I'll just share my screen. Okay, so you can all see my screen okay?
Yes.
Good. Okay, so yeah, this is a paper about product market concentration and productivity in the UK. So it's really a measurement exercise to look at what's happening to concentration in the UK, but it fits very well with the overall theme of the conference, but is not anything to do with the labour market or migration, which is what this session is about. Maybe something we can look at in the future is labour market concentration in the UK, but no, this is all product market concentration, and I suppose it's got labour productivity in it. I should just state this disclaimer because this is important. This is confidential data that's been released by the ONS for the purposes of this research. The use of the ONS statistical data in this work does not imply the endorsement of the ONS in relation to the interpretation or analysis of the statistical data. The work uses research data sets which may not exactly reproduce national aggregates. And this is funded by the UK Research Council through a couple of grants and also an ONS, an Office of National Statistics grant. So the main motivation for this work is to say, well, market power seems to be increasing in a number of developed countries around the world. And we don't really know what's happened to the UK. Well, there's not been too much research on that front. So we're going to dig into that a little bit. And secondly, the UK has a severe productivity puzzle, which is a big decline in productivity post-financial crisis that seems to have persisted for a long time afterwards. So we're going to see if these two things can be linked together at all, which leads to the questions, what's happened to market power in the UK? In this case, we're going to talk about concentration. There are, of course, other measures that you can look at. And how is that related to productivity, specifically labour productivity here, or a proxy for labour productivity? And the answers we'll find are pretty simple. So concentration in the UK is actually quite flat. Not much has happened. You haven't seen the same kind of sharp increases that you do observe in some countries, notably the United States. Things will differ slightly if we exclude the financial services sector. So excluding financial services, you will start to see some increases in product market concentration throughout the UK. And really in some sort of trivial concentration productivity correlation type analysis, is we find that increases in concentration typically are associated with decreases in productivity. So there's a negative relationship. When a market is more concentrated or it sees an increase in concentration, it tends to be negatively related to productivity. So one of the main outputs, in addition to sort of this analysis we're doing in this paper or this report, one of the main outputs of some of this research is to produce a tool that allows you to look at different measures of concentration in the UK across different levels of industry disaggregation. So that's available here. I would click on it, but I'm worried that the share screen feature might mess up a bit. So I'll just leave you there with the address, but that tool gives you all the different breakdowns of concentration that you can see for the UK. It also provides labour productivity at the sort of 2-digit industry level. And things like entry and exit, so business dynamism measures as well. So we're working on this. This is getting developed more and more as I speak, and we're providing lower levels of disaggregation. So that's one of the things to kind of report from this work. So let's just give a quick overview of what we understand about product market concentration in the UK. So just very briefly, concentration is how much of total revenue share in an industry does a firm or a small subset of firms have. And that's what we're looking at. And there's been a few investigations into this in the UK. The first one to point out is a paper by a sort of a policy paper by the Resolution Foundation, which is a think tank actually. And they sort of show that concentration in the UK is increasing between 2004 and 2016, and it's increasing by quite a lot. They use this BSD data, which is what we'll also use, but we'll come to some different conclusions, and I'll explain why. And then the second quite prominent paper is a speech, a paper attached to a speech that Andy Haldane gave at Jackson Hole in, I think, 2018. But that's mainly about market power in general, so it focuses a lot on markups, and it has a small section on concentration where they say that the top 100 firms in the whole economy have seen an increase in their market share. That's based on a proprietary data set by Thomson Reuters, the ESCoE data. So they don't have the sort of granularity that we're going to have in our analysis. Then in addition to that, you've got cross-country analyses that include the UK. So work by Tommaso Velletti at Imperial shows sort of does an analysis of several countries using Euromonitor data, and it shows that concentration seems to be modestly declining in the UK, among other places. And then outside of the UK, the places that have garnered interest in this, what's happening to concentration in the aggregate economy rather than just specific industries, what's happening overall, are typically things to do with the US. So that would be the Gutierrez and Philippon work, showing that concentration increases a lot in the US, more so than the EU, and the Grulon, Larkin, Micheli work that shows 75% of industries in the US have seen an increase in concentration since the mid-90s. And then work by the OECD, Chiara Criscuola's team, shows in general in Europe concentration is increasing, excluding, not including the UK, and that uses a couple of different data sets to show that quite robustly. And then I'm going to go on and say, why do we care about concentration? So there's one thing looking at concentration and documenting what's happened to UK concentration, which is what we do here. And then there's another thing about either what causes it or what are the implications of that. And one implication can be that concentration or market power is related to productivity, and the UK has a big productivity puzzle. And the second part of this research is going to look at how does concentration relate to productivity in the UK. That's a bit controversial because, as many people know, an increase in concentration can mean one of two things. It can mean that you have less competition in a market, so there's less reasons to invest and to scale and to work resources harder, which diminishes productivity. So there could be this negative relationship, or conversely, it may just be indicative of a very efficient frontier of firms, implying that an industry is concentrating because because it's got an efficient frontier, and it's quite productive. So they could go both ways. And these kind of regressions, where you take a measure of market structure like concentration, and you try to explain some sort of market outcome, fall into this sort of structured conduct performance critique, which is there's lots of endogeneity issues you have to be careful with. On the one hand, concentration could cause productivity. There's this reverse causality problem, but vice versa, a productive frontier could lead to concentration emerging. So we have to be sort of mindful of that, and typically in empirical IO, you'd get much more sort of astute measures of changes in competition by focusing on very minute industries where you have clearly identified changes in competition. So in addition to this, it's going to be useful to have additional cross-country evidence from the UK to understand, if the UK behaves differently, if its concentration isn't increasing like in the US or in some European countries, why then is that the case, and how can we rationalize these different experiences? Okay, so this is what we call the UK productivity puzzle. You can see that productivity in the UK over the 90s is increasing fine, and then it sort of gets to the Great Recession period, and it goes off a bit of a cliff. So you have a big levels fall. This is output per hour or output per worker. They tend to track each other. And then it takes a long while for the levels of productivity to revert to their pre-crisis level, the 100 benchmark. And equally, the trend line through here is much shallower than the trend line through here. So you see this big decline in growth, productivity growth. So I'm mainly going to talk about the levels, the difference in levels. And sort of the UK productivity puzzle is this more short-run phenomenon than people often think of the US as longer-term productivity slowdown. We're a bit different to that. Okay, and then I should give some policy background to this. So there's also a very crude sort of policy motivation that the policy authorities in the UK are rather interested in what's happening to market power in the aggregate, as evidenced by a couple of initiatives at the moment. So this is the Department of Business getting in touch with the competition authority to say, you know, we need a better understanding of how things are behaving in the aggregate across all markets, not individual markets. So can you complete a commission to address that? So that's part of the UK policy background. They recognise that we understand competition well within industries, but we have very little understanding of the aggregate picture. So we're sort of coming in here a bit. And then there's this rebuttal from the Lord Tyree, who sort of heads the CMA, the Competition and Markets Authority in the UK. And they get back and say what they're going to do. And one of the things that they recognise is that productivity has been very weak since the financial crisis, and a better understanding of these type of aggregate measures will allow them to make better judgments. So there you have a bit of the motivation and the sort of policy background that surrounds this research. So moving on to the data we deal with. We're going to use something called the Business Structure Database. And this is an annual snapshot of all firms in the UK. So you have sort of it grows from about 1.5 to 2 million firms over the time period that we look at. It's a firm level data set which exists for tax purposes. You're put on this register if you either pay VAT, value added tax, meaning you have revenue over £85,000, or you have at least one employee, so a PAYE registered employee. It records sales within the domestic economy, so turnover recorded for UK tax purposes. So the pros of this data set are it's pretty much universal. You're covering all firms in the UK and 99% of economic activity from 1997 to 2018. So it's also quite up to date. We're waiting for the 2019 data to come online anytime in the next month or 2 months or something like that. So you do get this quite up-to-date picture of what's going on. And the limitations of the data set are, it's very few variables. There's not a lot you can do with this beyond looking at concentration and how it's sort of correlated with some other features, like we'll look at revenue per employee as a proxy for labour productivity. So the comms are limited variables. We also need to bear in mind that there's a lag in reporting. So when I start to show you some plots that have the time series on the x-axis, you need to sort of slightly lag in your head what's going on, because submission in 2010 to the BSD, so accounts recorded in the BSD in 2010 probably cover economic activity throughout 2008, 2009 for most firms. And I'm going to analyze a couple of subsamples of data. We'll do the full subsample, and then which we'll focus on mainly today, the most naive approach. Let's just analyze everything and see what happens. And then a subsample which drops finance, which is very important in the UK. It makes up 30% of revenues or something like that. Utilities, health and education, things where revenues are not a good proxy for output. So we need to be careful with defining what a market is in order to get our concentration measures. We also should be careful about what is a firm in this data set. So a firm is a so-called enterprise unit. An enterprise unit is is a business or a company that basically has accounts. So it has some financial record. It's bigger than a local unit. A local unit would be a warehouse or a store or something. But 95% of enterprise units in the BSD have just a single local unit. So they're typically one and the same. There's then a who owns whom reference, which is a much bigger level of aggregation, which goes across various, can include various enterprise units. So I sort of think of this as a, Mike Ashley owns Newcastle Football Club, but also owns various high street retailers, all of which would be separate enterprise units, as a hypothetical example. Then, so we're working with enterprise units. Mostly we're going to work with enterprise units. We plan to do some stuff on the who owns whom reference in the future, but we've been slowed down a bit due to COVID. We haven't been able to access the data for many months, as you need to use your office computer and that sort of thing. And so our market definition, we're going to firstly do the whole market, like in the Bank of England research and a few other papers. So just look at how have the very top firms in the whole of the UK been acquiring market share in recent years. And then we'll go down to the two-digit SIG industry. So there are about 85 of these, or there are 85 of these. And that goes to the level of granularity, such as veterinary activities, civil engineering, manufacture of food products. So that's going to be what we think of as a market here. Of course, all the firms within there will not necessarily be competing in an antitrust market with each other, but that's a sort of well-known issue here. There are a few different so we're sort of thinking of concentration as a proxy for competition. There are a few other things you can look at. So in this data set, we also do some sanity checks by looking at things like firm dynamics, so how much entry and exits going on, how much churn is there. We're going to look at CR5, which is how much of sales in a market, so in an industry here, so how many sales, for example, in the veterinary activities industry go to the top 5 firms, go to the top 10 firms, go to the top 50 firms. And then there's also the Herfindahl-Hirschman index as another measure, which is the sum of the squared market shares. So this is the first measure we produced, the first sort of descriptive statistics, shows entry and exit in the UK. So entries typically, this is sort of unsurprising, you see entry exceeding exit for most of the 2000s. There's this great recessionary period where there's a lot of exit and a much less entry than you'd normally have. So we're talking in rates here. So this would be 10% of firms in an industry are new entrants, or the number of exits is 10% of an industry, the number of entrants is 10% of an industry total. And then the bottom brown line is the net rate. So you see net over the recessionary period, we're losing firms, but most of the time there's some net entry throughout this time series, except post 2016, where we see things change again. And this is of course post Brexit. So that's probably having a role to play there. But what this shows is that there's not, for example, in the US, you see this declining business dynamism. There's this declining entry and exit. You don't really see that in the UK. You've pretty much got flat, not too much to report here, except we see events happening that would correspond to kind of cyclical things that we observe in the economy. So then we go on to the most trivial measure of concentration, which is defining the market as the whole economy, including every sector, what's happened to concentration. And you see that it's primarily flat to potentially declining over the last decade or so. So you've gone from CR5s of 10% to CR5s of say 7%, something like that, for the top 5 firms. This is going to be a bit conditional on, and you see this little decline, you see this little decrease in the post-Brexit period. And this will be a little bit conditional on whether you're including finance, because a lot of those top firms, the top 5 firms, top 20, top 10, top 20, top 50, they'll include big finance firms which have these huge orders of magnitude larger revenues than other industries. So you exclude finance and a couple of other sectors, but mainly finance is the influence here. And what happens is you'll see again, defining the market as the whole economy, concentration increases over the period. And then it declines quite sharply during the post-Brexit period. So this is sort of how we rationalize our findings with what was found in the paper I mentioned at the start by the Resolution Foundation. It's sort of very, very conditional on whether you're including finance in here. They also begin their time series much later. So they begin in 2004 and they end it in 2016. So that obviously gives you a pretty much maximum increase in concentration. But here, by the end, you've already reverted slightly.
10-minute warning, Anthony.
Thank you, thanks. So this is then the sales weighted. So this is when you weight across the two-digit sectors what happens to the aggregate concentration ratio. And you see again, this is pretty flat. You see the decline post-Brexit. So I'll comment on this in a second. But generally, concentration it's not following the same story that we've observed in some countries, from what we can see in the data, at least. And then going to the two-digit level, which you can analyze with this tool that I promoted a bit at the start, this kind of concentration analysis tool that we produced. You can look at all the different industries and how they're changing. Yeah, there are 85 two-digit industries, and over the period, there's pretty much a mixed bag of what goes up and what goes down. So again, it's reinforcing this idea that concentration seems to be quite flat. You see 40, by HHI, you see 40 of these 85 seeing an increase in concentration and 45 see a decrease in concentration. By CR5, you see 42 with an increase and 43 with a decrease. Even if you go to a more sort of recent period, there isn't much there as well. A slight majority are decreasing by CR5, and again, it's almost 50-50 for HHI, 43 versus 42. So we conclude that concentration is flat or decreasing in most UK two-digit industries. So it's kind of a negative result, but it seems to be important at a time when lots of people are jumping on a sort of market power concentration bandwagon to get some facts out there for the UK to understand what exactly is going on and try to rationalize how different experiences may have been felt throughout these different similar economies. Oh yeah, and this is my slide commenting on what we see post 2016. So the UK voted to leave the EU in the summer of 2016, and we've got a couple of subsequent data points, and very soon we'll have the 2019 data point. And it tends to show by all these measures that there is quite a sharp deconcentrating of the top firms. So it's 64%, so 54 of the 85 industries see a decreasing concentration over after the Brexit period. So you can say that the top firms have suffered relatively more in terms of losing sales than firms lower down in the hierarchy. That might be consistent with this sort of winner takes most story, the superstar story that we've heard a bit about in the past few years, which is the idea that concentration is really, the causes of concentration, rising concentration throughout the world is because of globalization and large firms being particularly good at what they do and acquiring lots of share because of it. Similarly, if you have something like Brexit, which is perhaps a sort of deglobalization shock, these firms are suffering relatively more. So that's what you observe. As a quick sanity, so I'm going to go on now to running some partial correlations or these regressions between labor productivity on the left-hand side and our measure of competition or concentration on the right-hand side. Just a sanity check, if we run, we're going to use sales per employee as the measure of labor productivity here. And just in aggregate in the data set, it looks quite similar to the official plot I showed you at the start. You have this increasing productivity over the 2000s, a decline post 2010, post financial crisis, and it takes many years to get back to an equivalent level. So that seems to add up. We'll run the following regression, which is sort of flavors of an early paper by Stephen Nicol in the mid-90s, which is first difference. It has industry and time fixed effects. And we include sort of concentration from last period, just this lag of concentration to say, you know, that concentration in a previous period may affect productivity going forwards, but contemporaneously, it would be very difficult to determine which way around the causality runs. Controls in this are going to include age, size, market share, and we include various other things as well, just to test that these results hold. And this interaction term is designed to, so we have net entry here, which is another indicator of competition. We have an interaction term, which is to sort of designed to distill so-called good concentration from bad concentration. The idea being, if you're conditional on you being in an industry where there's kind of a dynamic amount of entry, net entry is taking place, concentration should have a relatively weaker effect, or shouldn't have as much of an effect on productivity. So it should have a dampening effect, or concentration is taking place for the kind of good reasons. You're concentrating because there's a sufficient frontier of firms, as validated by it being a sort of dynamic industry, one with lots of entry. So we're going to find this concentration coefficient is negative, as we might expect when there's, as you'd expect if you were to believe the hypothesis that concentration is somehow indicative of inverse competition. More concentration, less competition weakens productivity, and we indeed find that. So we say that here we have a few different specifications. The left-hand side, as I say, is log of labor productivity. The right-hand side is the CR5. So an increase in CR5 typically decreases labor productivity with a significant effect, and that effect becomes much less profound or when you interact with it being a so-called dynamic industry. It differs a little bit across sectors. So depending on the individual sector, you might observe differences, which is to be expected when you think production perhaps has more scale economies or something that leads to a positive effect. Seth, do you have a question or a timing update?
3 minutes.
3 minutes. Cool. We then check how robust this result is to different definitions of concentration. And what you'll find is that the signs all point in the same direction. The precision of the result decreases slightly. So these are not significant at the 90% level, but they're not completely insignificant, right? These are about 1.5 standard deviations away from the null. So something like 87% significance in these results. So generally it's showing that there's this negative correlation between concentration and productivity in the UK data. And we have to say this is very much the first analysis we've done. So there's statistically significant negative correlation between the concentration and productivity. The economic significance is somewhat modest because these have been scaled. So the interpretation here would be a 10 percentage point increase in the concentration ratio reduces labor productivity, revenue per worker, by about 0.4%. So that's the sort of the economic significance, which is, if you think of those graphs I showed at the start, labor productivity falling about 4%, 5% following the crisis, you're talking about 1/10 of that is what this is relative to. So I was saying this is the sort of first naive analysis. You've included lots of stuff. We've not been too vicious in any sort of cleaning activities or anything like that. And we find there's economically modest significance and statistical significance. But the statistical significance becomes much more precise when you start to do some more robustness analysis. So if we were to drop observations of labor productivity exceeding the 2.5 standard deviations away from the mean, so the very high productivity firms, then you get a lot more precision in your results. So this negative result is a lot more significant. The economic significance is almost exactly the same. It's not an unreasonable thing to do this either, because you get a lot of these one employee in an administrative data set like this, where firms are registered for taxation purposes. You get a lot of these strange firms that could be sort of special purpose vehicles, that sort of thing, where you've got one employee recording $1 billion in turnover in one year and then not doing much after that. So that would strengthen precision. So just to conclude, I think I'm in time. Rising concentration is not that clear for the UK, but it is if you exclude finance. So that's how we can find similar results to what other people have presented. And concentration trends are much less aggressive than the US. Concentration and productivity are negatively related. And check out the app that we've done, which allows you to look at how things are evolving in different industries and that sort of thing. I see there's a question, I think.
There's one question. Michaela, can we unmute Michaela Vecchi?
Okay, yes, can you hear me?
I've got the question, thanks Michaela. Yeah.
Oh, okay, that's fine.
Yeah, we'd have to go to so as I sort of said at the start, this data set's advantage is very large, but there's relatively limited numbers of variables. There is another UK data set with which we could do that quite simply. But we sort of resisted doing that just because we wanted to keep this covering all the markets at the moment. So it's something we could do but we haven't done it for the time being. We'd have to merge it with the ARD essentially.
Okay, because innovation can affect both concentration and productivity. So one has the feeling that there is something important missing. Your analysis is fantastic, so there's nothing to take away from your analysis. Just in the future, perhaps it would be very interesting to see what happens if you can include innovation in there.
Thank you. Thanks. Yeah, it's a great suggestion. It is a direction we want to go, is to merge this with the more sophisticated data set that's available. So we can do that. Thanks very much.
Thanks.
So if people have additional follow-up questions for Anthony, I'd say follow up offline if you can. We're going to switch over to our next speaker, which is Giacomo Domini from Erasmus University. He'll be presenting his paper, Threats and Opportunities in the Digital Era, Automation Spikes and Employment Dynamics. And again, I just stress that if you want to ask questions, feel free during the presentations to type in your question into the Q&A feature.
Okay, so I'm going to share my screen. Okay, so good afternoon, everybody, and thank you for giving me the opportunity to present this paper, which is joint work with Marco Grazzi, Daniele Moschella, and Tania Treibich, based in Milan, Pisa, and Maastricht, respectively. I'm Giacomo Domini, lecturer at Erasmus University, Rotterdam, and this paper is a paper about the threats and opportunities associated with automation and its impact on employment. And we chose to talk about threats and opportunities in our paper's title because every time we talk about automation, in fact, every time we talk about technological change, there seems to be a mix of fear and excitement. On the one hand, it's seen as the main driver of economic and societal change, but on the other hand, there are widespread concerns that this might represent a major threat to employment. It's not a new debate, it's as old as industrialization, but it gained, let's say, an increasing momentum lately with the emergence of the technologies of the so-called fourth industrial revolution, and technologies, among which in particular digital technologies, digital and automation technologies, which are seen as involving, as presenting some new challenges which might make the results on employment different from what we saw in the past. In particular, the type of jobs that are affected by these recent technologies is much larger than in the past. It's not just about manual jobs being at risk. It's about any job that can be routinized. And secondly, the type of firms and sectors is also larger than before because these technologies are seen as involving a general rethinking of production processes. And despite the relevance of the topic, analysis of the impact of the recent wave of automation technologies on employment are not so many. The first evidence was at an aggregate level, and these first studies failed to reach a consensus. For example, Giacomo and Restrepo found a negative aggregate effect in the US, but then Dawes et al. And Grazzi and Michaels did not find significant effects, and Clarence et al. 2020 even finds a positive aggregate effect in the EU. Only more recently came micro-level evidence, so worker level and firm level. The very first contribution, to my knowledge, is the one by Bessen et al. 2019, worker level based on Dutch survey data, and finding that automation leads to a higher probability of separation for workers in automating firms. But then moving at the firm level, for example, Koch et al. And Acemoglu et al. 2020, find that that automating firms actually experience an increase in their employment after automating. And actually now the list of references got richer, and these result in this positive correlation between automation and firm level employment still keeps being found. So notice that, however, Acemoglu et al. 2020, which make both a micro and a macro aggregate analysis, point out that this finding of a positive effect of automation at the firm level for adopters still can go hand in hand with a negative aggregate effect, which they find. So we provide a contribution to this literature. We provide evidence on French manufacturing firms that are involved in international trade in the period 2002-2015. And some highlights of our paper are that we construct a firm level measure of investment in automation related technologies. I'm going to show in a couple of minutes that this is based on import data. We look at the effect of automation technologies on employment growth, but we are also able to decompose employment growth into gross worker flows, meaning basically the inflow of hiring of newly hired people and the outflow of people who got separated from the firm. Then we're able to study pattern
It looks like Giacomo may have had some internet issues. We'll see if he can come back on in just a moment.
Hello.
Great, we have you back.
Okay, can I restart?
Yep.
Okay, sorry about that. As I was saying, we contribute to this field of literature on the impact of automation on employment, but also to some different fields of literature, like that on investment spikes in general, the literature on gross, and finally the literature on studies looking at gross employment flows at the firm level, which is very scarce, also because the data that are needed to construct these flows at the firm level is actually quite rare. So what are our sources? We rely on three administrative sources. The first and main of which is DATS Post, which is an employer-employee database based on Social Security form, so administrative data, which contains worker-level information on the universe of French manufacturing firms with employees. And we restrict our focus to French manufacturing firms. Then we complement information from that with information from customs data from the French customs office, DG, DDI, which in its original form is transaction level. And in particular, we're going to use information on the type of the flow and the product code of the flow. And finally, we retrieve some firm level information such as value added and capital from Ficus and FAR, which are two more databases. One, FAR is the successor of Ficus from 2009. And these are firm-level administrative databases based on fiscal statements and containing general firm information and balance sheet information. We match these different sources at the firm level thanks to the unique firm identifier of French firms, which is the CRM. So now let me take a few minutes to explain the main variables of our analysis, starting from the gross worker flows. As I said, we do not just look at the net variation of employment in firms, but we're able to decompose this into the gross worker flows of hiring and separation. And we can do that based on the structure of that post database. Which contains information on all workers that are present in French firms, either on this year, T, or on last year, T-1. So we define hiring as a worker that is present on the last day of this year, T, but was not there on the last day of last year, T-1, and vice versa for separations. So if you are there, if you were there last year but are not there this year, then you are a separation. Notice that by definition, the net flow is equal to the difference between the inflow of hirings and the outflow of separation. And we can, of course, calculate rates of relative to these flows by dividing flows a la Davis Altivonger by the average employment over 2 years. Why is it important to look at gross worker flows? Well, because as you can see from this graph, modest dynamics in terms of net growth can actually conceal large dynamics in terms of gross flows. So this evidence shows that while the average net growth of French manufacturing firms was around 0, then the on average hiring and separations were equal to 20%. So there is a large turbulence that is concealed by net growth rates. Regarding types of workers, so composition of the workforce, our main variable, the main variable we rely on is a worker level occupation code known as categorie socio-professionnelle. It's a French categorization. It's standard in the empirical literature using French data, and it's something that reflects production hierarchies. To be clear about this, as you can see at the 1-digit level, we have these 4 layers, which are engineers and managers on top, then all the way down to production workers. And then, of course, if we go to the 2-digit level, then we we get some more specific categories. Among the 2-digit categories, we are particularly interested in CS38 and CS47 because these are the categories that Halligan et al. 2016 define as techies, meaning workers that facilitate the adoption and use of new technology. And given our research question, these are, of course, workers that we want to focus particularly. So regarding different types of workers, the category socio-professional is our main variable, but we want also to speak to literature that is not just on French data. And to do this, we map these CS categories into the occupations as per the International Standard Classification of Occupations. And after doing that, we are able to match ESCoE occupation codes to the values of the routine task intensity index that were calculated for European countries by Hoss et al. 2014. The routine task intensity index shows how the potential for of a job to be the routine content of a job, and therefore the potential to be threatened by routine bias technological change. And it was originally elaborated by Otto et al. 2014. And as you can see, different types of workers are characterized by different net growth rates and different gross worker flows, so hiring and separation. Finally, and most importantly, let's define our firm level automation variable. As I said before, we construct our firm level automation variable based on import data. And in particular, we identify for each firm whether they import certain capital goods that embed automation technologies based on a taxonomy by Giacomo and Restrepo 2018. What they do in that paper is to take all 6-digit codes referring to capital goods and then partition them into categories of automated and non-automated goods. We focus, of course, on the automated categories, which include, among other things, robots, industrial dedicated machinery, and numerically controlled machinery. After constructing this variable for each firm in each year, we can analyze the statistical properties of this variable, and this reveals that this variable behaves very much as we know investment variables behave, meaning it has a spike behavior, which means a couple of things. First, that it is rare across firms, so investment in imported automated goods is rare across firm. Only a minority of importers import actually these goods, 10% in each year. Then it is rare within firms, meaning among those who do import such goods, most of them do that only once or twice. And finally, the largest of these events accounts for the lion's share of all investment, all imports of such goods throughout over years for a certain firm. So if we rank the share that each year's imports represent in total import of these goods over years, then we find that the top ranked event actually accounts for a very large share, up to 70% of all investment in imported automated goods. So this is in general true of physical investment, as you can see from the left graph, but it's particularly marked in the case of imported automated goods. So based on this, we define this largest event for each firm as an automation spike. Now comes the question, what's the relation between automation spikes and employment? And we know from the literature on investment spikes that typically there is an interrelation between investment spikes and employment spikes. And this is what we can already observe from this preliminary evidence. This table shows the mean net growth rate, hiring rate, and separation rate around an automation spike for firms that have such a spike. So, and as you can see, the net growth rate is positive during and there is positive before and during an automation spike, then it turns into negative. And this decrease in the net growth rate is mainly driven by, is seemingly uniquely driven by decrease in the hiring rate. Let's now be more precise about this and move on to the regression analysis. And what we do is to estimate two models. Regression having on the left-hand side flow rates, so net growth rate, hiring rate, and separation rate, and a regression having on the left-hand side the shares of various types of workers. And on the right-hand side, we always have the same specification, so leads and lags of a dummy denoting the presence of a spike in a certain year, then fixed firm level fixed effects and time dummies. We are going to estimate these two models twice, so a first time using a simple fixed effects estimator, and a second time by complementing this fixed effects estimator by using weights based on the propensity to experience an automation spike, as I'm going to explain in a moment. Before moving there, let me just mention that our sample is composed of all French manufacturing firms that import at least 1 year over the time window we observe, which represent a minority of all manufacturing firms, but 84% of aggregate manufacturing employment. And finally, of these firms, we focus on continuing ones, which are more or less 91% of them, because we want to avoid that our estimates are influenced by extreme events of entry and exit.
10-minute warning, Giacomo.
Okay, thank you. So before moving to the results, let me explain these propensity score reweighting. So we do this to mitigate concerns related to the non-random selection of firms into automation. So it could be that fast-growing firms are those that decide to automate. This strategy is used also by Koch et al. 2019, which is one of the firm-level studies on automation employment that I reviewed before, and they are inspired in turn by Guadalupe et al. 2012. So how does it work? We basically estimate a probit regression with, on the left-hand side, the spike variable, the spike dummy, and on the right-hand side, we have legs of firm performance variables, including employment stock, employment growth, labor productivity, and so on. All these variables are related, have a positive impact on the probability to automate. After estimating this model, we take the estimated probabilities, and based on that, we construct weights that reflect the, that then we use to reweigh the equation, the estimations of equations 1 and 2. And just a minor note, this slightly reduces our sample, but it's really a minor reduction. So now getting to the results. First, these are the results of the simple fixed effects estimation. And as you can see, in line with the evidence that I showed before, there is a positive correlation between automation and the growth rate before and during a spike, and a negative one afterwards. And the positive effect before and during seems to mainly be driven by a reduction in the separation rate, and whereas the negative effect afterwards seems to be mainly driven by a reduction in the hiring rate. How do these results change if we reweigh our estimation? So as you can see, basically the reweighting reduces and virtually eliminates differences between spikers and non-spikers before the spike, but then we still have this positive coefficient in the year of the spike and negative coefficients in the years after the spike. And the contribution of wiring and separation seems to be more evenly shared in this case. Notice that even if there is lack of significance here, still the coefficient on the column under net growth rate can be decomposed into the difference between this coefficient and this coefficient. So the contribution seems more or less evenly shared. What happens to the composition of the workforce? Well, the results are pretty clear about this. There's not much that is happening on this side of the story. So as you can see, one-digit occupational categories shares are not significantly impacted by spikes. This is not just a matter of aggregation. If we go down to the two-digit level, we find a similar picture of lack of significance. And interestingly, the only mildly significant at the 10% level coefficient is associated to a category 47, which is one of the two categories that we identified as techies. And finally, even if we look at the share of workers in the top tercile of the routine task intensity index, then we similarly have a general picture of lack of significance. And this is particularly true for the second column, 2009-2015, in which our match of French categories to international categories is much more precise because we exploit the four-digit detail, which is not available before 2009. So we run an extensive battery of robustness checks that I'm afraid I do not really have the time to go through right now, but long story short, the main message from our regressions does not change. So to move to the conclusions, well, our paper shows that investment in imported capital goods embedded in automation technologies shows the typical spiky features of investment variables in general. We show a positive correlation with preceding contemporaneous employment growth, which then declines. And this is driven both by dynamics in the hiring rate and in the separation rate. And instead, we do not find differential effects across different types of workers. So our results, putting them into context, are in line with similar results, from similar firm-level studies. As I said, most studies find positive firm-level association between automation and employment in adopters. And this seems to be in line with a labor-friendly technological change view. And instead, our results pose some challenges to conventional routine bias technological change and job polarization views. And actually, it's interesting to observe that recent evidence is emerging also challenging these mainstream views. So thank you for your attention, and I'm sorry for the technical issue before.
So people should feel free to add their questions to the Q&A, and we'll allow you to unmute your microphone. Giacomo, I just had an initial question. Have you looked at all at this by firm age? Because I wonder whether or not the patterns are different by firm age.
Well, firm age is in the so it is on the. Let me actually share again my screen. It's not included as a control in the simple firm level fixed effects estimation, but is included, is one of the variables on which our weights are based. So when we include weights in our regressions, we implicitly also control for age, among other things.
My question is I wonder whether or not the patterns of investment are different and the effects of investment are different based upon firm age. So doing distinct analyses by firm age.
Okay, I see your point. No, we haven't done something, we haven't seen, we haven't run a separate analysis for, let's say, young and old firms, but we have run a separate analysis, a robustness check for large firms, and in as much as employment is also related to age, though not perfectly, well, this robustness check does not show a different picture for large and possibly older firms on average.
So I'm not seeing any additional questions. If anybody has an additional question, feel free to just put your name in real quickly into the Q&A. Otherwise, we'll transition on to the next presentation. Okay, great.
Well,
thanks, Giacomo.
Thank you. Thank you.
So I'll go ahead and share my screen here. Hopefully people can see my screen now. So my name is Seth Murray, and I need to begin with the disclaimer that the opinions I'm expressing today are my own and not necessarily those of either the US Census Bureau or the Board of Governors of the Federal Reserve System, and also that all the results have been reviewed to ensure that there's no confidential information being disclosed. So my presentation today is about how we can expand the set of questions that we can answer using our administrative employer-employee linked data sets. These employer-employee linked data sets are incredibly rich, and we've been able to use them to answer a wide range of important questions in labor economics, macroeconomics, and many other fields. But a key limitation of these data sets is that they tend to lack any measure of workers' wages or wage changes, and instead, they tend to just report workers' total earnings at some periodicity. So a key contribution of my talk today is that I will be presenting a set of methods that can be used to extract workers' unobserved wage changes from these reported quarterly earnings for workers. And the methods that I'll show you have two sort of broader takeaways. The first applies really to almost any large-scale administrative data set. And the key insight is that the information that would normally appear just as noise in survey data, oftentimes or sometimes can be extracted using machine learning methods from these administrative data sets simply because of the large scale of these administrative data sets. And I'll show you how this can be done in the context of payroll schedules using an administrative employer-employee linked data set for the US. The second takeaway is more specific to employer-employee linked data sets. And it is really an aspiration of mine that I hope that the methods I'm presenting today will be used by other researchers to answer questions that require both measures of workers' wages or wage changes and the richness of the employer-employee linked data sets. And so along these lines, in the second half of the presentation, I'll use these methods to present some evidence about the patterns of wage adjustment and how those differ for nominal wage cuts versus nominal wage raises. And I'll discuss the implications of these empirical findings for three common methods used to model wage adjustment. Namely, I'll be looking at Taylor-style annual wage adjustment models, Calvo-style random arrival of opportunities to adjust wages, and menu cost models of wage adjustment. So what I'll document is that the nominal raises tend to follow a Taylor-style annual adjustment pattern, whereas nominal cuts are much more consistent with a Calvo-style random arrival of opportunities to cut workers' nominal wages, and that neither nominal wage raises nor wage cuts seem to follow a menu cost model of wage adjustment. I'm going to be implementing these methods and generating the empirical findings using the LEHD data set. The LEHD is the US Census Bureau's employer-employee linked data set for the US. And it records each individual worker's quarterly earnings for each firm that the worker is employed at in a given quarter. And because it's derived from administrative unemployment insurance records, it ends up covering about 96% of employment in any given US state. So the LEHD can be considered as the sort of near universe of employment in any given US state. For this analysis, I'll be using a 10% random sample of firms from 30 states, covering the period from the first quarter of 1998 through the first quarter of 2017. So now I'll turn to presenting the actual methods that can be used to extract workers' unobserved nominal wage changes from their observed quarterly earnings data. And to start with, it'll be useful to sort of set the stage by considering the unobserved components that make up the observed quarterly earnings data. So here, what I'm going to be showing you is two representative workers, one salaried and one hourly. And the x-axis here indicates the quarter of the worker's tenure at a specific firm, whereas the y-axis corresponds to their quarterly earnings in each of those different quarters. Both of these workers are receiving a 3% nominal raise at an annual frequency. So that generates this sort of stair-step pattern that you see for the salaried worker. The hourly worker also has that same underlying stair-step pattern, but because of fluctuations in the hours paid in any given quarter, it's a much noisier quarterly earnings series relative to the salaried worker. So what I'm going to be doing is I'm going to be denoting the worker's observed log quarterly earnings by Y, and that's going to be for worker I at firm K in period T. And that's going to be a function of the worker's log wage, which is the W, and their log hours paid, denoted by H. But there are other unobserved factors that also determine workers' observed quarterly earnings. So one of those is variable compensation. This is going to be including things like annual bonuses, tips, commissions, overtime pay, those sorts of things. And this log variable compensation, V, tends to appear as spikes in the quarterly earnings series because variable compensation is typically in addition to workers' base pay. It's not like you go in and you say, well, what's my annual bonus for the year? And they say, well, this year we're going to deduct your pay by $1,000. That doesn't tend to happen. You may not get an annual bonus, but it's generally not negative. Perhaps, though, more problematic than this variable compensation is the noise that's generated by payday schedules. So here I'm just showing you what happens if I was to be paying these two workers at a biweekly frequency. What would their quarterly earnings look like? And you can see there's these massive fluctuations where you're going to see quarterly earnings changing by plus and minus 15 percentage points every single quarter, simply because the workers are flipping between having 6 to 7 and back to 6 paydays in any given calendar quarter. And this is going to make it so it's really hard to detect any sort of wage change in these quarterly earnings series, because yeah, you can see there's an upward trend here, but where those wage changes occur is really hard to detect given the magnitude of noise generated by these payroll schedules. So what I'm ultimately interested in is the unobserved changes in W. But how can I get there from this very noisy quarterly earnings series? What I'm going to do is I'm going to describe two of the steps in that process. I'll focus first on the identification of the number of payday weeks for each individual worker, and that's going to clean up a lot of this noise. And then I'll describe the estimation procedure for then using that cleaned up series to estimate the wage changes. I also, in the paper, develop a set of methods for identifying the sort of spikes that occur because of variable compensation, particularly annual bonuses. But for the purposes of time, I'm just going to point you to the paper for those. So let me begin by describing how to eliminate the noise generated by payday schedules. So there's a couple of key insights here. The first of which is that there's actually a limited number of potential payroll schedules that firms can pay workers according to. If a firm is paying a worker weekly, then there's 7 days of the week in which the firm can pay that worker. So there's 7 different payroll schedules. If instead the worker is being paid biweekly, then there's 7 days this week and there's 7 days next week where the firm could be paying that worker. So an additional 14. Or firms sometimes pay workers, or oftentimes pay workers on a semi-monthly basis. And so there's essentially about 22 different payroll schedules that firms will use to pay workers. And so what I'm showing you on the right here is what those patterns look like based upon the payroll schedules. So the ones that sort of look like heartbeats where it's flat and then it spikes around and it's flat again, those are going to be your weekly payroll schedules. The ones where it looks like you're going for a run, it's just going up and down, up and down, up and down, those are your biweekly payroll schedules. And the ones that, the one that looks like me after I've gone for a run, where it's just a flat line, that's your semi-monthly payroll schedule. So the key thing that we're going to be using here is the fact that each of these different payroll schedules, you can go and look at the calendar and see exactly how many paydays would have occurred in a given calendar quarter if you were being paid according to that particular payroll schedule. And you can do this for each of the 22 different payroll schedules and for each period in time. So what that then allows me to do is say, okay, for each individual worker, I want to do the following. I want to find which of these different payroll schedules minimizes the variability of the worker's observed quarterly earnings series. So if I was to subtract off the log number of paydays according to that particular payroll schedule, what does that do to the variability of each individual worker's earnings? And you can see here, if I say, well, what about payroll schedule number 1? When I subtract that off, it doesn't do very much, still very noisy series. If I look at payroll schedule number 2, still a very noisy series. Payroll schedule number 3, though, when you get to the right payroll schedule, it dramatically cleans up the variability of the observed quarterly earnings when you adjust for the number of payroll schedules when you get to the correct payroll schedule. And so what I do is for each individual worker, I'm going to be going through and looking at all 22 of these different payroll schedules and finding which are the ones that minimize this variability, the variance of the worker's adjusted observed quarterly earnings. Then what I'm going to rely on is the next observation is that any given firm actually only tends to have a small number of these potential payroll schedules, where typically it's only one, sometimes it's 2 or 3 different payroll schedules that they'll use to pay workers at the firm. And what this invites is then a clustering algorithm, where I'm going to say, okay, first, for each individual worker, I find which is the payroll schedule that minimizes the variance of their earnings for all the workers at this firm. And then I implement a clustering procedure that looks and says, well, what is the payroll schedule that the most workers at the firm agree on? And you can see when I do that, the first one it picks up is this payday schedule number 1. And that becomes the first payroll schedule in operation at this firm. And I look at the remaining workers and I say, well, is there another payroll schedule that a majority of workers or a large set of workers at this firm agree on? And sure enough, there's one more payroll schedule. It's payroll schedule 19. And so I say, okay, that becomes the second payroll schedule in operation at this firm. And again, the algorithm continues and says, well, is there yet a third payroll schedule which a large set of workers at this firm agree on? And the answer is no. So the algorithm then stops there and says, okay, for the remaining workers, what we want to do is we have 2 potential payroll schedules at the firm. Which of these smaller subset of just 2 payroll schedules minimizes the variance of each individual worker's earnings? And so this is how you identify both the set of payroll schedules that are in operation at the firm in general, and which of those is actually applicable to a given worker. So that's great. Now that I've identified how to identify these payroll schedules, I'm going to now get to is well, how do I use that information to then go and think about the persistent wage changes? So here you can see I've got the 2 very noisy original quarterly earnings series. The first thing I'm going to do is I'm going to subtract off and adjust the series for this estimated number of payday weeks. And so I'm going to be focusing on this sort of adjusted payroll schedule. And in the paper, I'm actually also adjusting for some forms of variable compensation, namely the annual bonuses. What I'm going to do is I'm going to focus on Y tilde, which is this adjusted quarterly earnings series. And I'm going to have the wage, which I'm interested in. And then there's going to be this error term. The error term is going to include the hours and any fluctuations in hours worked by the worker. But then also it's going to include any error in my estimation of either the variable compensation or the paydays. So this reduces down the problem, but now I still don't observe anything on the right-hand side. I don't observe the actual wage I'm interested in. The first thing I'm going to do is I'm going to say, well, the wage that I'm paying you in period T, that can always be written in a recursive formulation. So what I'm going to do is I'm going to say, well, that can be written as the initial starting wage for the worker, which is WIK1, plus every wage change that the worker's experienced up until period T. And these are the delta Ws, what I'm ultimately interested in here. This is great, but still I don't observe any of this. What I now want to do is I want to rewrite this in a more of a regression format, something that's going to look more familiar to us from a regression framework. And what I do for that is I say, okay, if this worker has been employed for capital T periods at the firm, so that's the total tenure of the worker at the firm, I'm going to construct capital T distinct dummy variables. And these are the Ds, the D1 through D capital T. And each of these dummy variables takes on a value of 1 if the current period T is equal to or greater than the period in which that dummy variable is associated with. So D1 you can think of as the intercept term. It's always taking on a value of 1 because the first period is equal to it and every subsequent period comes after it. Each of the subsequent variables, so like say D2, it's going to be 0 in the first period, and then it's going to take on a value of 1 for every subsequent period. And so what that means is the beta coefficients basically turn on once you reach that period and then stay on for every subsequent period. So what that means, you can interpret these beta coefficients as the actual wage changes that occur in a given period. This is wonderful, but still it doesn't get me where I need to go because I have capital T observations for an individual worker at a firm, and I have capital T dummy variables. But the next thing that I'm going to rely on is that workers don't tend to receive wage changes in every single period. Many of these beta S coefficients are actually zeros. And so it becomes a variable selection problem for which the lasso procedure is ideally suited. Where the lasso procedure is going to identify which of these dummy variables should have their beta coefficients set to 0, implying no wage change occurred in that period, and which of them have non-zero wage changes. To just give a little bit of intuition behind what's going on with the lasso procedure, it has 2 different components to it. The first is in this first brackets with the square term, you're going to recognize as the standard minimization of the sum of squared residuals that we do in OLS. So finding what are the beta coefficients that allow you to best fit the observed pattern of adjusted quarterly earnings for this individual worker. But then there's this additional term, the lambda times the sum of the absolute value of the beta coefficients. And this is what's turning it into a variable selection problem, where if the algorithm wants to have a beta coefficient that's non-zero, because having a non-zero beta coefficient for a particular period really helps better fit the observed pattern of quarterly earnings, then it's going to have to pay a penalty for that. And so what this is going to do is it's going to drive a number of the beta coefficients to be 0, and then it's going to identify which of the periods in which actually the wage changes truly occurred in. So this is the procedure for then identifying the actual wage changes for each individual worker. I do this for each worker at every single firm in the economy. And the nice thing about the lasso procedure also is that it's a very scalable procedure. So when I'm using this for tens of millions, or in some cases even hundreds of millions of workers, it still works in terms of the scalability of the procedure. So how does this stack up and compare against other analyses that look at quarterly earnings for individual workers? There's a ton of studies of annual wage changes, but there's actually remarkably few analyses that identify the quarterly frequency of workers' wage changes, which is what I'm sort of going to have to benchmark against here. I'm aware of only 2 of such studies for the United States. Well, the first is this Baratieri, Basu, and Gottschalk 2014 AHA macro paper, where they look at the SIP. And they actually use a procedure very similar in spirit to what I'm proposing with the lasso procedure to try to identify and address measurement error in survey respondents' reported wages in the SIP. They find that between 15 to 20% of workers receive a wage change in any given period, and almost 1 in 5 workers are having no wage change quarter over quarter. The more recent study by Grazzi, Hurst, and Yildirim is using administrative payroll data from the ADP payroll processor. And they're focusing on firms that have at least 50 employees. That's who this particular ADP data comes from. I think this is sort of the gold standard right now, simply because this is the actual data that's used to run firms' payroll. So you actually are truly seeing the wage that's going into workers' payroll. And they find that about 1 in 5 workers are receiving a wage change in any given quarter over quarter period. And the majority of these are raises. You can see that nominal cuts are very rare in the data. So how does my procedure stack up against this? I find something very similar to what they're finding. I'm finding that about 15% of workers receive a quarter over quarter wage change, and that the vast majority are raises rather than cuts. So that's the procedure. Now I'm going to actually go and say, well, how can I use this procedure for useful economic purposes? There's other papers I've done also using this procedure, but I'm going to focus here on how do we analyze different models of wage adjustment that have been proposed, and what are the implications of the microdata for the validity of these different models. So let me just begin by showing you that just like in many different data sets, we find significant evidence that nominal wages using this procedure exhibit a significant amount of downward nominal wage rigidity. There's a large mass of workers who are receiving no wage change. This is a year over year histogram of wage changes. there's a bunch of workers who are receiving raises, but very few workers who are receiving nominal wage cuts. And if you were to do something more rigorous, where you do like a regression discontinuity analysis at 0, or some of the other procedures trying to test for whether or not there's downward nominal wage rigidity, in all cases when I run those procedures, I find very strong evidence of downward nominal wage rigidity. So next, I want to look at the probability that a worker actually receives a nominal wage change given the time elapsed since the worker last received a wage change. And the reason why is because this is actually going to be very informative for evaluating some of the different models that have been proposed in the literature. What I'm showing you here on the x-axis is the number of quarters since the worker last received a nominal wage change. What I'm showing you on the y-axis is the probability that the worker actually receives a wage change in a given period. Excuse me. I'm plotting two different series here. The blue line shows the probability that a nominal raise occurs. The red dashed line shows the probability that a nominal cut occurs. There are two features that I want to focus on here. First, the blue solid line for nominal raises shows strong evidence of a Taylor-style annual staggering of raises, where the probability that a worker receives a raise spikes every 4-quarter anniversary after their last wage change. And you can see this at 4 quarters, at 8 quarters, at 12 quarters, and so on and so forth. When you look, however, at the red dashed line for nominal cuts, there's no similar tendency to spike at any particular frequency. And so it looks like the Taylor kind of a model really does align with the nominal raises, but doesn't seem to capture what's going on with nominal cuts. The second feature I want to emphasize is that the probability of a nominal wage raise is declining over the time since your last wage change, whereas the probability you receive a nominal wage cut is relatively flat since the time you last received a wage change. This is informative because a Calvo-style model of the random arrival of opportunities to adjust wages would imply that you should see a very flat series rather than a declining series. And so the fact that with the nominal raises, we see that the probability you receive a wage change is decreasing since the last time you received a wage change really runs counter to what we'd expect if Calvo was applicable to nominal raises. Whereas it really does seem like the nominal wage cuts are very consistent with a Calvo-style model of wage adjustment. So next, I want to focus on the menu cost model side of things. And for this, I'm going to be borrowing a modification of a procedure that was first proposed by Sprit Khan in her 1997 AER paper, where what she's doing is saying, okay, look at a wide set of wage change histograms over time periods. So in each period, calculate your own distinct histogram of wage changes. The same real change in different periods will correspond to different nominal wage changes, just simply because inflation differs from one period to the next. And then what she says is, she says, okay, well, what you want to do is you want to look and say, well, what's the probability that the same real wage change occurs when that real wage change, that same real change in one period requires a nominal cut and another period does not? Or in one period requires a very small nominal raise versus in another period requires a large nominal raise. And this is informative in two ways. First, when you look at the nominal cuts, it's going to give you a sense of the degree to which requiring a nominal cut suppresses the optimal real wage changes. And you can see the fact that there is a large and statistically significant negative coefficient here really means that there's a large suppression of nominal wage. When the same optimal real change would require a nominal wage cut, about 50 to 70% of those optimal real wage changes just don't occur. The second thing, which is more applicable to the menu cost models, is that the menu cost models will predict that when a wage change that is of the same real wage change magnitude, but when that requires a very small nominal change, that it's going to be less likely to occur. Because if it only requires a small nominal change, then the firm's not going to get much benefit from adjusting the worker's wage, because if I only need to raise your wage by, say, 0.5 percentage point, that's not that far from zero, which is just a wage freeze. And if menu costs are applicable, then probably I'll just leave your wage at zero, even though it's not the optimal wage, it's close enough. So the fact that here we're seeing a strong statistically significant increase in the probability that small wage changes occur is going to be inconsistent and really actually counter to what you would expect if a menu cost model actually holds. This is, however, consistent with Mike Ellsby's hypothesis that you might, because of downward nominal wage rigidity, see compression in the distribution of wage changes around zero. And that is exactly what we're observing here. So let me turn to just concluding with just talking about some of the implications of these empirical findings about wage adjustment patterns for how we model wage adjustment in macro models. The first is just thinking about nominal wage cuts. And the nominal wage cuts really seem to follow a Calvo-style random arrival of the opportunity to cut a worker's wage if that is what is optimal. Whereas there's no evidence that Taylor or menu costs are actually consistent with the nominal cut phenomenon. Whereas nominal raises instead really seem to follow a very strong pattern of Taylor-style annual staggering. Again, menu costs don't seem to fit nominal raises at all. There's some evidence that I found looking at the Calvo style, but it's quite weak as to whether or not there's some random arrival of opportunities to adjust workers' wages, like for instance, if a worker receives an outside offer and that may cause the firm to raise the worker's wage. That might be the sort of random arrival Calvo style adjustment. So what does this mean in terms of the dynamics of how we should be then modeling wage adjustment in our macro models? The first is I think that we should be thinking about distinct adjustment procedures for nominal raises versus nominal cuts. That we would want to use a Taylor style nominal raise procedure, whereas a nominal cut procedure should be following a Calvo model procedure. And this would mean that for the same real wage change, depending on if it's a nominal raise versus a nominal cut, there are different patterns of adjustment that we should be incorporating into our macro models. This is going to generate a much richer set of dynamics in our modeling of business cycle models in sort of two ways. First, it'll generate state dependence in wage adjustment, because in downturns, you're going to see a shifting of the distribution of optimal wage changes towards the left, towards zero, and towards negative values. And that's going to mean that you're going to see the incidence of both nominal wage freezes and nominal wage cuts rising as the Calvo procedure becomes more relevant during downturns. And that's going to generate a lot of state dependence in wage adjustment. Second, it's going to generate asymmetries in the response to positive versus negative shocks, since the persistence of shocks depends on whether or not you're using a Taylor or a Calvo style model of wage adjustment. If there are some workers where it's just going to take me a long time to be able to adjust their workers' wages downward, then, which is going to be consistent with this sort of Calvo model, then I need to be setting workers' wages taking into account that it may be years before I'm able to adjust their wage down. Whereas if instead I want to be able to adjust a worker's wage up, I know that if that's following a Taylor procedure, you're going to be able to do that every single year. So with that, I'll conclude and open up for questions. But again, I just want to stress that I really hope that other researchers can use these procedures with either the LEHD data set or other administrative employer-employee linked data sets.
Thank you, Seth, for this presentation. I would like to ask a small question about this. Your analysis so far is for the whole of the economy, or have you explored any, let's say, sector-specific analysis or analysis for different types of workers, blue collar,
yes,
for example?
Yes, so there are interesting patterns there about the frequency of wage changes and how those differ. On the worker side of things, it's not actually in this paper, but it's in a different paper, which I could point you to. If people are interested, just shoot me an email. But you're seeing that the incidence of wage changes are different for particularly low-income workers versus higher-income workers. And that then has in the US significant implications at sort of on a racial basis as well, where the methods of adjustment, for instance, for low-income workers in the US are really being oftentimes driven by minimum wage changes. which is not really so true for the higher income workers. And also, another thing I'd say with higher income workers is that the variable compensation tends to become a more important component of their overall compensation, which imparts some flexibility in their total earnings that may then be consistent with why we observe differing patterns of layoffs for low income versus high income workers during recessionary periods, where the flexibility that occurs because of greater variable compensation on the part of high income workers may make it so it's easier to retain those workers during downturns, which is less true for workers where there's no variable compensation component or very little variable compensation component. There's also differences that we observe across industries. There's differences, for instance, in the timing of this Taylor-styled annual adjustment, which appears to actually differ a lot across industries, where within industries, there's a lot of clustering where firms will coordinate the timing of their wage adjustment with other firms. And it is not an explicit, unlike in some countries where it's really driven by unions, that's not the case at all for the US. Unions are just such a small percentage of overall employment, but you still see that within some industries, there is significant coordination of the timing of this annual wage raises that go on.
That's very interesting. Thank you.
Yep. So I think we're at time. Again, if people have additional questions, they should feel free to follow up with any of the speakers. And I thank everybody for your attention.